We're up to question 7, review set 4b. We know that the integral of a function, or the definite integral between x is 1 and x is 4, is 3. Right? Imagine it as an area under a curve. Now they want us to use that information to find the integral of f of x plus 1. So a way you could do this is to split the integral into 2. I've got my dx's dx. All right. We know this one is 3, and we can easily work out this integral of 1. Right. So this will equal 3 plus antiderivative of 1 is x. We need to evaluate that between 1 and 4. All right. That will be 4 minus 1 is 3. So the answer is 6. Units squared, or just the number. I think just the number's fine. Right. They're not asking me for an area under a curve. They just want the definite integral, so just the number. There's another part to this question. Okay, let me write this down. See if we can fit it on here. Okay, so it's saying the integral between 1 and 2 of f of x dx minus the integral of from 4 to 2, right? It's going from a higher value to a smaller value. F of x dx. So what I'd be doing is looking at this information. If I have the integral from a to b, right, of some function dx, that's the same as negative of the integral from b to a. Right. You can maybe think about calculating area under a curve where, you could just think of your fundamental theorem of calculus, probably the easiest way to think about it actually. So your a's and your b's have been swapped around, and so you're going to get the same number but negative. Right? So you just verify it for yourself like that. Maybe you could think of it as area under a curve where, if you're working backwards, instead of this way, as you go along with your widths, your infinitely small dx's, those values are now negative. Right? So your changes in x are becoming very small negative numbers, which means as you're doing your infinite sum, you're doing height times a negative effectively. So it's not too difficult to understand why that happens. And what it allows us to do is to flip these numbers around, which you'll see in a minute is going to be useful for us. All we have to remember is that if we're going to flip those numbers around, we're going to get negative of what we had. Okay, so this will be minus minus, which is effectively now plus. Minus and negative, same as plus. All right. Now this integral can be expressed as one integral. All right. We could say the function's continuous. We're going from 1 to 2, and then from 2 to 4. It's the same as just going from 1 to 4. Right? There's no, to do calculus, we're always assuming continuity of these functions. So there's no gap at 2. We could say this is the same as the integral of 1 to 4, which we already know because they told us that right at the start of the question, and the answer was 3. So that question's now done. It's testing your knowledge of the properties of integrals. So do you realise that you can swap those around if you change the sign, And you want to make sure you read this bit in the book and you understand it. There's questions earlier on which get you to prove that using fundamental theorem of calculus. And this property where you can combine integrals, I think it's fairly straightforward, but there'll be a green box on page, I think it's here maybe, I'm not seeing it. Properties of integrals, definite integrals, I'm not seeing them, but they'll be in the book somewhere. Oh, there it is, page 109. Right? So that question was really using the green box from page 109.